Hey Algebra 1, this is your second video on a two-part series that covers how to solve absolute value inequalities. First example I want to take a look at is this one right here. Absolute value of x minus 2 minus 3 is greater than or equal to 8. Okay, so once again, like we saw in the previous video, anytime we see an absolute value with a greater than or equal to, this clues us in on this is going to give us an OR graph. Okay, so first thing we want to do is just like in the previous videos, you want to get that absolute value of x minus 2 by itself. First thing we got to do is add 3 to both sides of that inequality. When that happens, absolute value of x minus 2 minus 3 plus 3 causes my 3's to cancel when they combine. Absolute value of x minus 2 is greater than or equal to 8 plus 3 is 11. Okay. Now remember, this results in an OR inequality. Here's how we go about solving it. Remember, just like in previous examples, we would always get a positive number and a negative number when we solve absolute value equations. Something very similar happens here, but we have to be careful of my inequality sign. Okay, so the first thing we need to do is obviously do the positive example. X minus 2 is greater than or equal to 11. When we go to do the negative side of this, watch what happens. I get x minus 2 is less than or equal to negative 11. Okay, so we've got to make sure that with the negative example, we flip this sign around to be less than or equal to. And so what we do is we just solve like normal. Add 2 to both sides of the inequality. We get x is greater than or equal to 13. And then we do the same thing here. We add 2 more. That gives me x is less than or equal to negative 9. Okay. Going to graph these, once again, let me see, because I just discovered a new tool on my Active Inspire here. If I go to graph my line, this is pretty cool. Check this out. Whoa! So then I go ahead and graph it. I get 13 on the left, negative 9 negative 13 on the right, negative 9 on the left. I know my numbers, I promise, and my number line. Close circle over negative 9, close circle over 13. I shade everything to the left, and then I shade everything to the right on 13, shade everything to the left on negative 9. I know my directions, I promise. So that's how we represent the solution set for this absolute value inequality. Okay, remember, everything kind of hinges on our absolute value, the sign of the inequality. Okay, looking at another example here, let's say we have kind of a simpler example. Let's say we have the absolute value of x minus 1 is less than 8. So this is already solved for, and because this is less than, that clues us in that this is an and inequality. Okay, here's how we graph an and inequality. We do this. We once again want to start with negative 8 and positive 8. Positive 8. And then we put this into a compound inequality that looks like this. Okay, and we once again want to solve from the inside going out. So I'm going to start by adding 1 to get x in the middle. So I'm going to add 1 to negative 8, add 1 to positive 8. And that's going to give me negative 7 is less than or equal to x, which is less than or equal to 9. Okay, so now what I can do is, because I have x in the middle of my compound inequality, I can go ahead and graph it. Once again, take a look at this cool tool. Whoa, there goes my line. Okay, so once again, everything between negative 7 and positive 9. Close circles for both of them because it's less than or equal to. And then everything gets shaded in between because that's how we represent an and inequality. Once again, if we wanted to rewrite this as a verbal example, we would write it as all my numbers x that are greater than or equal to negative 7 and all my numbers x that are less than or equal to 9. Okay, so that's kind of a verbal translation of this compound inequality. Okay, another example I want to take a look at is this one right here. 2 times the absolute value of x minus 3 plus 4 is greater than or equal to 8. Okay, now I want to warn you about something. This right here, these absolute value bars, they actually do not operate as parentheses. Some of you may see that and say, hey, I want to distribute. That will not help us in solving it. We want to leave that alone so that way we know that this is what we need to get by itself. All right. Nonetheless, we get a greater than or equal to here. This clues us in that this is going to end up being an OR graph. Okay, so once again, we want to get the absolute value of x minus 3 by itself. I'm going to start by subtracting 4 from both sides of the inequality. When that happens, I'm left with 2 times the absolute value of x minus 3 is greater than or equal to 4. All right, and then last step, as always, divide by whatever is right in front of what we're solving for. When I do that, I'm left with the absolute value of x minus 3 is greater than or equal to 2. Okay, so just like we saw in the previous OR example, I want to break this up into 2 smaller inequalities. I'm going to be left with x minus 3 is greater than or equal to 2, which is kind of the easy example. And then the other one is x minus 3 is less than or equal to negative 2. Okay, kind of shows that difference in sign here. If I go ahead and add 3 to both sides of the inequality, 3, there we go. I get x is greater than or equal to 5. Okay. And then if I add 3 to both sides here, I get x is less than or equal to positive 1. Okay. Let me draw my line here because I like using this tool now that I've discovered it. And I go ahead and graph it. So all my numbers greater than 5 on the right, all my numbers less than 1 on the left. We want to represent this as an OR inequality. So it's everything away from that number there. Okay? And here's how we can relate this. Remember, we said earlier that if we look at this inequality, this would be my numbers that are 2 or more away from 3. Okay? We can see that. So once again, this is translated as numbers that are 2 or more away from 3. So if we know that that's what that's going to look like, we can just go ahead and graph it. I just solve it so that way you guys can see how I end up with these numbers. Okay. Last example that I want to take a look at. This guy right here. 3 times the absolute value of x minus 3 minus 7 is less than or equal to 2. Okay. Just like in the previous example. We have a lot of steps we need to take care of, but this sign right here clues me in that this is going to be an AND inequality. Okay. So it's going to be the intersection of 2 separate disjoint sets. So first thing, once again, start by adding 7 to both sides of the inequality. That leaves me with 3 times x, absolute value of x minus 3 is less than or equal to 9. Divide everything by 3. That gives me the absolute value of x minus 3 is less than or equal to 3. Okay, so once again, kind of like in the last example, we should expect to see all numbers that are 3 or less away, because it's an AND inequality, from 3. Well, then you're thinking, well, that's going to be easy because that's going to be 0 and 6. Let's just double check here to make sure. So I get x is, oh, I want to do an AND inequality. That's right. So that means I got to set it up where I have positive 3 and negative 3 on both sides. So negative 3 less than or equal to x minus 3 less than or equal to positive 3. If I go ahead and add 3 to all 3 parts of my inequality, I end up with, hey, what do you know? 0 less than x less than 6. Okay, and I use my favorite tool again right here. Put my number line there because that's so much easier than drawing a line by hand. I put 0 on the left, 6 on the right, close circle here, close circle there, and I'm left with everything in between to represent this graph. And once again, if we put 3 in the middle, we can kind of visually see that 0 and 6 are both 3 away from 3. Regardless if it is to the right or to the left, it fits this boundary here. Okay? So make sure you have these notes written down. Review them as you need to. Your homework is to do worksheet 30 and 32 as they exist on Google Classroom. Okay? This will be due by the end of this week. So by Friday the 30th, this is when this worksheet is due. Talk to you guys later.